Civic Tech is so happy to welcome the amazing and important insights from Dr. Madeleine Bonsma-Fisher. This is very interesting stuff. She's going to talk about from bacteria to bikes, quantitative cycling research in Toronto. Very interesting. You've got an open-eared audience here tonight, for sure. Dr. Bonsma-Fisher turned her hobby into her job as a data scientist, quantifying the impacts of cycling infrastructure in Canadian cities, including advocacy, citizen science, and the latest research on cycling in Toronto. Take it away, Madeleine. Madeleine, just give us a moment while we sort out the sharing. There we go. You can see behind you.
There we go. Okay.
Perfect.
Yeah, looks great. Okay. Am I correct that I'm not mic'd in the room, or is the room mic'd as well?
The room is mic'd.
Can you hear me okay? Yeah? Okay, good. I have a very quiet voice, so I was, okay. I'll try to project as well. It is a huge delight to be here and an honor, and thank you all so much for coming. I am honored to share with you today the story of how a biophysics grad student whose papers that no one read became a local bike personality, whose papers some have said that they have read. And the story is actually very short. In 2017, I attended a Civic Tech Toronto event with Matt Elliott, this one right here. And I think that everything that happened next has just flowed from that. Like that's the story. And if you were there, you probably know Matt's awesome. So I first came to Toronto in 2014 to start a master's program in physics. And for the next 8 years, I studied how bacteria, that's the green blob in this image, defend themselves against phages, which are the orange mechanical spider terrifying things here, which are viruses that infect bacteria. And I learned how bacteria change their DNA to defend themselves against phages, and how phages evolve themselves to stay one step ahead of bacteria. So this is a simulation that I made during my PhD of bacteria and phages evolving together. And the different colors here represent different genetic strains of phages in bacteria. And the size of each circle is the population size of each strain. So the phages are getting new mutations to try to escape from the bacteria's immune system. And the bacteria immune system is following the phages and kind of copying their sequences over time. So that's all I'm going to say about this. This was my PhD in 30 seconds. But all along, I had strong feelings about transportation. And this is a tweet from almost 10 years ago, the day of my physics qualifying exam. Nothing like a harrowing bike-to-yo commute to put my physics qualifying exam today in perspective. When I got to school to do my exam, I was glad to be alive, and it made me feel less nervous about my exam. So as I became more interested in the way we design cities and angry about biking, I decided to do something about it. I got a cargo bike right here. I joined Bike Ottawa. I made a train costume for my cargo bike. I got a research position studying cycling infrastructure, and I got another cargo bike. And so for the rest of my time with you, I'd like to tell you about some of the results of our research and one new project, which I'm very excited to make its public debut tonight here for you. As many of you know, I think probably all of us know, cycling for transportation is a really amazing thing. It's fun, it's low cost, it's good for the environment, it's safe and healthy. This picture on the left, you might recognize as Danforth near Broadview. And on the right is a picture of my son and a friend biking in Ottawa on an off-road path. But as we also all know, there are many places that are not safe or comfortable to bike. And this is photos from a group ride that I did in 2023 in Scarborough, in Toronto. And you can see that without the group riding together, this would be a very uncomfortable place to bike. There's no separation from cars, there's fast-moving traffic, multiple lanes of cars. So in my research, I developed quantitative ways to measure the impact of cycling infrastructure. So I'm trying to answer who's benefiting from cycling infrastructure and where should we build new infrastructure to have the most impact. So to preview what I'm going to tell you, I want to share with you one finding from our work, which is that the most useful infrastructure that most improves your ability to get around safely is not always the infrastructure that is closest to you. And I think this will be obvious when we get there, but it wasn't necessarily obvious to us when we started this. So we use level of traffic stress to quantify cycling safety and comfort. These categories, these 4 categories here, were developed from surveys that identified 4 groups of potential cyclists. One very small group, about 4% of adults, that are fearless, willing to ride in mixed traffic with fast cars around them. A small group, still small, about 9 or 10% of people that are confident, who would ride in something like a painted bike lane on, Kingston Road, just to name a random road in Toronto. And then a very large group of people that we call interested but concerned. So these people are not willing to cycle with dangerous cars. And then a 4th fraction of people who will never bike no matter what, so we don't really think about them when we're talking about planning. They're not the people that could potentially be biking. So those got translated into these categories with an extra category called level 1, which is considered suitable for everyone, including children. And so every road and path can be rated in the system on a scale from 1 to 4, where 1 is, again, suitable for anyone. 4 would be extremely unsuitable for most people. And so the criteria in your mind, I want you to think of this as like low stress LTS 1 and 2 would be something like a cycle track, an off-road path, or a calm residential street. And we'll talk more about that as well. And then high stress is anything where you're kind of next to or with fast-moving cars. So this is a map of Toronto with every road and path rated in this system, level of traffic stress. So high stress here, can everyone see this okay? Okay. High stress is orange or yellow and red, and the arterial roads are shown in thicker lines here. And so the 2 things that I want you to take away from this image, oh, there's a thing at the back too. Oh, that's so good. Okay. But the 2 things that I want you to take away. First, most of the arterial roads, the thicker lines, are high stress. And where there are low stress arterial roads, they're mostly downtown, which is where we have like cycle tracks on Bloor Danforth, for instance. The second thing I want you to notice is that there is also a lot of low stress roads in the city, but they tend to be residential roads. So most residential roads we consider low stress because they have low vehicle volumes and low speeds. And so even though there's no specific infrastructure, they're still comfortable to bike on. But the problem is that if you imagine starting a journey on a bike in a low stress neighborhood here, you quickly hit an arterial road that is going to prevent you from going any further. So we have these islands of low stress infrastructure that are captured, that are surrounded by high stress. Okay. The second step of quantifying bike infrastructure that we do is called measuring accessibility to destinations. So this is a measure of how many places you can reach. For us, we do using only low stress infrastructure. So if you start from your home or your workplace, where can you reach if you stay only on these low stress roads? And we use a time cutoff of 30 minutes biking at 15 kilometers an hour. So for example, if I start at my home near Main and Danforth, and I'm going to swimming lessons, I can bike down Danforth and then south on a residential street. And yes, I can get to swimming lessons on low stress roads. So that's an accessible destination for me. But if I'm going to music lessons up here, I can try a few different routes. I can again come down Danforth, but then I hit this high stress road here. Can try going through Taylor Creek. Again, I hit Bayview, I get stuck. Same thing here, I end up stuck on Bayview again. So this destination is not accessible using only low stress roads. And you can also see this on the map if you look at the boundary of high stress roads here. At some point, you are forced to use one of these roads to get there no matter which way you're coming from. So we count up all the destinations you can reach from any starting point in the city using only low stress roads, and that is our quantification of how useful the bike network is for you. And why does this matter? In early research from our group, not that I was involved with, but before I joined, they found that the number of jobs that you can access using low stress infrastructure is highly correlated with your likelihood to bike for your trips. So this is a metric that is predictive of likelihood to bike. Okay, so, oh, yes, and this is sad. I do still bike there, but I'm sad about it. This is a map of now accessibility to destinations for different origin areas in Toronto. And what you'll notice is that it's highest near downtown, where the yellow colors are. And that's both because, like we saw in the previous map, the cycling network is more low stress near downtown. There just is more low stress infrastructure, but also there are more destinations there. So there's a combination of land use and transportation working together to produce this result. Okay, I want to introduce that. Okay, so our group is using this to optimize new infrastructure. So we want to answer the question, which high stress roads should we convert to low stress to maximize the destinations you can access, now that we believe this is a useful measurement of how good the cycling network is. So when we do that, for the entire city of Toronto, what we find is that the optimal new infrastructure, which is these red lines here, is all clustered near downtown. And we think that's because of the existing network being most developed near downtown. So you're going to get more kind of synergistic effects from new infrastructure if you connect to the existing network. But there's a bit of a catch here. Do we really want to maximize accessibility for the entire city? If you can access 30 grocery stores, do you need to access 31? Or is it more important to give somebody who can access 0 grocery stores safe access to at least 1? So what I did in my work was we tried a few different optimization goals to take different variations of equity into account. And I'm going to share just one with you today, a version of spatial equity. So instead of giving an entire budget just to the entire city, what we did is we split our new infrastructure budget by the pre-amalgamation boundaries of Toronto, which are shown up here. People still have fights about the city based on these boundaries, so we think that they are still interesting to talk about. So what we found was very interesting. We found that the optimal infrastructure for origins within a region was not always in that region. So if you can see Scarborough here in blue, some of the optimal projects for Scarborough are in Scarborough, but some of them are in Old Toronto. So they're actually not in Scarborough at all. So this is another way of saying this, is that the best new infrastructure to improve accessibility by cycling for people that are in Scarborough, starting their trip in Scarborough, is not even in Scarborough at all. And I also want to draw your attention to this section down here. I'll use my mouse as well. This is Bloor Street West, our old friend, the Bloor West Bike Extension in Etobicoke. And we did this with the 2021 cycling network when this had not yet been built. And we found in every case that we checked that this section of Bloor was coming up as optimal. So whether you consider the entire city as a whole, whether you consider just Etobicoke, it's still important. And even sections that aren't in Etobicoke are important for Etobicoke's access. So, you know, that's something. Somebody cough, cough, Doug Ford. And, you know, I would be sad that they didn't listen to us. And I'm kind of extra sad because we did specifically try to tell them. This is an image that from a report that we submitted to the Bill 212 Parliamentary Committee. And I presented some of our work there as well. We specifically looked at what would be the impact on accessibility to destinations if Bloor bike lanes, Bloor West bike lanes, Yonge and University were removed. And so what this image is showing is the fraction of people who cannot access that area as a destination if those lanes are removed. And in particular, I want to again highlight Bloor West. You can see you can see where the Humber River is on the map by the divide in accessibility here. You can see that Bloor West, if you have infrastructure, is providing a critical link to areas west of the river. And if you don't have that, then people lose almost all of their access in some cases to these areas. Okay, so again, to summarize what I've just told you, the most useful infrastructure for you to get where you're going is not always the closest infrastructure to you. And the route to your destination is a big part of the benefits that you get from cycling infrastructure. That's my main takeaway from our research for you today. And as somebody who was a cycling advocate before I became a researcher, I understand the value of making research public and the value of having this information accessible. So I am very excited to share that our group has launched a website, cyclelinks.ca, to calculate changes in accessibility to destinations from new cycling infrastructure. So this was with support from the Data Science Institute. We worked with a wonderful software developer to make this website that does two main things. The first thing that it does is you can pull down pre-computed optimal solutions from our model. So you can say, if I want to build 40 kilometers of new infrastructure, this is the 40 kilometers the model recommends. You can also then turn off and on specific projects. If you have your favorite project that you really want to see built, you can try it out in this website and see the change in accessibility and write to your city councillor and say, if you build a bike lane on Parliament or Kingston Road or Bayview, just to name a few of my personal favorites, this would be the change in accessibility. So please try it out if you like. I'm not going to demo it now because it's a little bit slow, but it is fun to work with. And I'm going to end there. Thank you to the people that I've worked with along the way. So this is my... I'm going to thank the people that I've worked with. This is my supervisor for my PhD, Sid Goyle. My current advisors, Shoshana and Tim. Bo Lin is the PhD student in our group who made this optimization model that I'm using. And Connor is the Data Science Institute software developer that made this website for us. Thank you.